Hello everyone, our topic for today is inverse variation. So inverse variation is another type of proportionality. Now in inverse variation, if the value of one quantity increases, then the value of the other increases. And it is represented by y is equal to k over x. Okay, and when x increases, y decreases. So we can see here that if x increases, the value of x increases, though the value of y decreases, and vice versa. Here, again, if x decreases, then the value of y increases. So again, same with direct variation, our k represents our constant of proportionality, and these are the most common keywords used in inverse variation. Varies inversely as, is inversely proportional to. Now again, to fully understand inverse variation, let's have examples. So for example number 1, if y varies inversely as x and x equals 5 when y equals 2, we'll find y when x equals 10. Okay, now our solution for this one is we're going to make a formula. Y is varies inversely, that will be k, y equals k over x. Okay, then we will solve for the constant of proportionality by replacing the value of x and y. Y here equals 2 k over x equals 5. So our constant of proportionality k is equal to, multiply 2 and 5, that will be 2 times 5. K here is equal to 10. Okay, so the same thing, we're going to replace our k here in our formula y, that will be y equals 10 over x. Now next thing is we're going to find y when x equals 10. So we're going to replace x equals 10, so that will be 10 over, our x here is 10, so over 10. Then therefore y equals 1. So let's examine that one. Y equals k over x. So when our value of y is 2 and our x is 5, now we're going to increase the value of x to 10 from 5 to 10. So we are increasing x to 10, therefore the value of y decreases. So that's why our value of y becomes 1, from 2 to 1. Okay, now let's have another problem. Y is inversely proportional to x such that y equals 4 when x equals 15. Find y when x equals 20. So again, let's make a formula. Y varies inversely, that will be k over x. So we're going to replace x and y to give the value of k, our constant of proportionality. So y here is 4, k over x is equal to 15. Therefore our constant of proportionality k is equal to, we're going to multiply 15 times 4, you get 60. Again, we're going to replace k to our formula, y equals k over x. So we're going to replace, that will be y equals 60 over x. Now we're going to find y when x equals 20. So replacing our x here equals 20, that will be 60 over 20, and y equals 60 divided by 20, that will be 3. So our y here equals 3. And for our final example, we have your speed varies inversely with time. So if a motorbike goes to a certain distance in 3 hours at 190 miles per hour, what speed is needed to go to the same distance in 2 hours? So this is another inverse variation problem. So again, we make a formula. Let's we let s as our speed. Speed is equal to varies inversely with time, that will be k over time, t. Okay, then we will solve for constant proportionality by replacing our speed and time. Our speed here is 190 miles per hour over is equal to k over our time is 3 hours. So let's solve for the constant of proportionality. That's 190 times 3. You get 570. Again, let's replace k in our formula. So that will be s is equal to 570 over t. Now we will find speed needed to go to the same distance in 2 hours. So we're going to use the formula s equals 570 over t. Same distance in 2 hours. So that will be s is equal to 570 divided by time 2 hours. So s here equals 570 divided by 2, that will be 285 miles per hour. Our unit is miles per hour. Okay, so that's all for today. See you next time in my next video. Thank you.